All right, my phone decided to cut off in the middle, so we'll continue with this part. We're going to work now on literal equations, and what that means is that there are more than one variable. There's more than one letter, so to speak, in there. And if you look on your note-taking guide, it tells you to decide what you're going to solve for, and that has to be given in the problem. They have to tell you which letter to solve for. And then you just follow the same procedures as you did with linear equations. So I'm solving for x according to the instructions they give me for number 73. So I want to undo any addition and subtraction first. So I'm going to add b. Now the difference in this is that we can't actually add b to c. So we just put b plus c. If you put c plus b, that's fine, because in addition, the order doesn't matter. Again, focus on that we're trying to solve for x, and the a is connected to the x by multiplication. So to undo that, we need to divide, and that causes those a's to divide out, and my answer becomes b plus c over a. Now, the difference in this kind of literal equation is that your answer is not going to be a number. It's going to be a series of other letters, other variables. All right, we're going to move on down to number 75. And again, I'm solving for x according to the instructions in the problem. And I've got some fraction stuff going on. So the easiest thing to do is to clear out those fractions by multiplying, by the least common denominator. Since our denominators are a and b, our least common denominator is the product ab. When you multiply ab times this fraction, the a's are going to cancel and you get bx. When you multiply ab times this fraction, the b's are going to cancel and you get ax. And when you multiply ab times c, you get abc. Now, I'm going to remind you that just like when we were solving equations that had fractional coefficients, you have to multiply every term by the least common denominator, not just the ones that have fractions in them. All right, so now I have this, and I'm solving for x, but I've got x in two different terms that I can't actually add together. So what I have to do is to factor out that x so that I can then divide both sides by the quantity b plus a to get x, that's going to divide out, equals ABC over b plus a. And that's my final answer for that problem. All right, we're going to move on down to number 79. In this problem, I was told to solve for r. And so, again, I've got some fraction stuff going on. So I'm going to multiply every term by the least common denominator, which is going to be r times r1 times r sub 2, the product of those three denominators. So I'll multiply every single term by that same thing. Now, when I multiply that by this one, these r's are going to cancel, and I'm going to end up with r1 times r2. There's my equal sign. When I multiply this one, the r1s are going to cancel, and I'm going to get r times r sub 2. When I multiply this by this fraction, the r2s are going to cancel out, and I'm going to get r times r sub 1. Now, remember, I'm trying to solve for this r, and it's in two different terms. So just like I did before, I'm going to need to factor that out. so that I can separate the R from the other variables in there. Then that will allow me to divide both sides by the quantity R2, R1, so that those will divide out, and I get just R by itself, which is what I was trying to solve for. And so that makes my answer be R sub 1 times R sub 2 over R sub 2 plus R sub 1. Now again, because this is addition, if you had it in the reverse order, that would still be correct for that problem. All right, we're going to move on to number 80. And we're told in this problem to solve for this little r. And so the first thing I'm going to do is to distribute and get A equals P times 1 plus P times RT. That's a P. And reminder, I'm solving for the little r. So I need to undo addition and subtraction first. So I'm going to subtract this P from both sides. And I get that. Focusing on that I'm solving for R, and what's connected to the R is this P and T. And the way they're connected is by multiplication. So I can undo multiplication by dividing. So I'm going to divide both sides by the quantity PT. That causes those P's to cancel out and those T's to cancel out. And I get just little r, which is what I was trying to solve for. And so my answer becomes A minus P over PT. I'll caution you when you're using MyMathLab, if there's a capital letter, be sure you use capital. If there's a lowercase letter, be sure you use lowercase, because it will matter. All right, moving on to number 81. I'm solving for this r, which is in a denominator. So the first thing I'm going to do is multiply both sides by that r so that I can clear out the fraction part of it. And on this side, I get r times f. And since I'm solving for r, and I got to get rid of the f, and it's multiplied, I'll do that by dividing. And so I get mv squared over f. And that's my answer for that one. All right, number 82 is a pretty easy one. We're solving for t, and the only thing that's connected to this t is n and r, and they're connected by multiplication. So all I have to do is to divide by that quantity. That causes the n's to cancel and the r's to cancel, and leaves me with just t, which is what I was solving for. So this becomes my answer, PV over NR. All right, number 83 up here. We're told to solve for this little r. I've got a denominator thing, so I need to multiply by that denominator, which is a quantity, 1 minus r. So that's going to cancel and give me a. But when I multiply here, I'm going to get s times 1 and s times negative r. So I get that. And I'm solving for the r. This is an s, not a 5. It looks like a 5, but it's really an s. So I need to undo this s, and it's positive, so I need to subtract it. And that's going to zero out, and it's going to give me the negative SR. And over here, I'll have A minus S, because I can't actually subtract them. Now, I'm solving for the little r, and I got to get rid of this negative s, and it's by multiplication, so I need to divide. That's going to divide out and give me r, which is what I was looking for. And on this side, I have a minus s over negative s. Now, while for me that would be an acceptable answer, my math lab does not like negatives left in the denominator. So they're going to want you to multiply both numerator and denominator by -1, the reason being to get the negative out of the denominator. So that's going to become a positive s in the denominator. And when I multiply -1 times a, I get a negative a. And when I multiply -1 times negative s, I get a positive s, which can be written as s minus a. Oh, sorry, you can't see that. Sorry. Okay, so here's where I multiplied. And I'm just rewriting this instead of negative a plus s, I'm changing it to s minus a. Either one of those forms would be acceptable, but they don't like you to leave a negative in the denominator. All right, so now we're on number 84, and we're going to be solving for this t. So I'm going to undo the addition first by subtracting v sub 0. So I get regular v minus v sub 0 equals negative gt, because that's going to zero out. I'm solving for the t, so I got to get rid of the g, which is multiplied, so I have to divide both sides by that. So this is going to divide out, and I get t, which is what I needed. And on this side, you see I've got that negative in the denominator again. So I'm going to multiply both numerator and denominator by -1 so that my denominator will be positive, and my numerator is going to have a negative v and a positive v sub 0. So I'd probably write it like this, with the positive v sub 0 and then the negative v. That's the end of this video, which is the second part of 2. So now you should be ready to do homework assignment number 2.